Physical significance of RMS value of current. Do you remember the physical significance of average value of current? Right? It was that value of DC for which? It was that value of DC for which?
Same charge flows in the circuit.
Same charge flows in the circuit in the same time interval, right?
Yes.
Is that so? Similarly, this is also the same thing, but will different. It is that value of a DC current passed through a resistor which will produce the same amount of heat in the same time interval as it was. So suppose if I have a resistor of R, the same resistor R is there, and let's say I have connected this to a alternating source, and in this case I have connected it to a direct current source, right? Everyone is able to see an AC source over here, and
Yes,
everyone is able to see a DC source over here. In the case of an alternating current source, a current will go as a function of time, whereas in this case the current, whatever current will go, is basically the DC current, and that is basically called as the RMS current. Okay, so it is that value of DC current which will flow through the circuit, which will produce the same amount of heat. Can you see in this resistor, when this current will flow, what will happen? This resistor will produce certain heat, right? So what is the heat produced in the resistor? Is it equal to, if suppose I is the current, then the small heat which is produced is basically I square into R into dt. If I flow the heat to a very small interval of time, then will the heat be equals to this? Can you see the small heat produced is I square R into dt? Everyone remembers this formula? I square R is basically the power, and dt is basically the time interval. The power multiplied by time is basically what? Heat. Yes? Yes or no? So if
yes,
I
sir.
say
Yes, sir.
this is the heat H1, which will be basically integration of dH, and that will be the integration of I square R dt. From where to where I'm doing? I'm doing it from time t1 to t2. The same amount of heat shall be produced in this DC circuit as well. In this case, the heat produced in the resistor will be given by H2, let's say, and that will be equals to I square RMS into R into what was the time interval? Delta T. So I square RMS into R. So can you see that value of DC current for which the same heat is produced in both the circuit? So please remember, this H1 and this H2 should be equal. So for the same heat to be produced in the circuit, to the same time interval t2 minus t1. Can you see the time interval is also same? The time interval is also same, right? So same heat produced in the same time interval, that value of DC current is basically called as what? the RMS current flowing in a circuit. Is this clear? Is this clear, guys? Physical significance clear hai? Just like the graph, we had the physical significance of this as well. The RMS value of a given alternating current, RMS value of a given alternating current can be defined as that value of DC current which produces the same amount of heat in a resistance which the AC circuit produces in the same direction, in the same. One more thing. Here also, here do this particular thing, in the same direction as well. Here don't change the direction of current. In the same direction, it should be there in the AC circuit when I'll just write this one more thing. एक छोटा सा part you need to add a little bit more in the definition.
So, but how do you not change the direction in an AC source? Like,
Yeah, but
it's
if you
basic
take it,
characteristics.
if you take only for a half cycle, if you integrate it only for a half cycle, then what will happen?
We're supposed to consider only a half cycle.
Yes, so in the half cycle, the direction does it changes?
No, sir.
Okay. AC circuit in that resistance in the same direction of current. One more line we need to add. So just tell me whenever you're done to scroll up or down. Guys, whenever you're done, just tell me, okay? पाहुणे होते ना रात में झाले की दोन पाहुणे भरलेले. Done, guys? Shall I scroll up or down? Please write it and write it fast.
So done.
So I think the physical significance is pretty much clear, right? It should produce the same amount of heat. In the average current, it was the same amount of charge, right? So I could explain you the graphical analysis, but this is a little bit typical. So इसलिए ask your math sir कि sir RMS value का graphical significance बताओ, okay? Now let's try to find out the RMS value or effective value for a sinusoidal AC, right? So suppose, for example, if I have a current, a sinusoidal AC I have, this is the current and this is the time, and it goes like this, then this, then this, right? Yes or no, guys? So
Yes,
this
sir.
is 2t, capital T. This is T, this is T by 2, and this is also, this is 3T by 2, right? So this is a sinusoidal AC, and for the sinusoidal AC, what is the equation? I is equals to I naught into sine omega t, right? Yes or no? Can you see over here the peak value can be both positive as well as negative? Yes or no? The peak value can be positive as well as negative. It can be plus I naught and it can be minus I naught in both the cases, right? Yes or no? What will happen when you will square it? What happens when you square this thing? Guys, can anyone tell me what will happen if I square this function? If I square this function, then will it become I square is equals to I naught square sine square omega t? Will it become something like this?
Yeah.
Yes, sir.
So if I say it will become something like this, then can you see when you are squaring this particular thing, nothing will remain in the negative half cycle, right?
Hmm.
So can I say this particular thing? If I say uh, this is the circuit now, if I try to draw the graph of this function, t versus I square, right? So let's say I naught square becomes something like this. And can you see for the same time period, it will have, the graph will change like this. For the negative cycle as well, the graph will change like this. Yes or no? Can you see again a positive half cycle? You draw it perfectly ना मेरे से थोड़ा it's not possible for me to draw exactly and try to draw it, but okay guys, you understood this particular thing. Can you see if I try to draw the graph of I square versus t, then this will be plus positive value always, whether it was in the negative half cycle, still it will become positive, right? So can you see in this case the peak values are always positive irrespective of whether it's the current was plus I naught or the current was minus I naught. Is this clear? Yes or no? Can you see this function is basically now repeating from here only. So also one more thing will happen apart from this. Can you see the function will start repeating from t by 2? Earlier it was starting, repeating from one cycle was completed till t. So now the time period of this function, is t by 2, not t. Okay. Here in this case the time period was t. So here the time period became t by 2. And please remember, if time period will become t by 2, that implies the frequency will get doubled, and also the angular frequency will also get doubled. Is this clear? Is
Yes,
this
sir.
clear, guys? Frequency is ka f and angular frequency was omega. So is this graph clear to you? What exactly I have drawn? Guys, is this graph clear? So
Yes.
whenever I squared, can you see this? Whenever a sinusoidal function is squared, then this new function has a time period of t by 2, not t anymore. Okay, we'll see this mathematically as well. Why? Don't worry. So anyways, now after this, what to do? We know this particular thing. I RMS is basically under root of I square average. Yes or no? Basically, if I try to average this particular thing, then automatically I try to find out average of this function, and let's just put the root over it. So can I write this particular thing? I RMS is basically equals to what? 1 by T2 minus T1, T1 to T2 I square dt. This is what we already know, right? And there will be one more root sign as well. Yes? Yes or no?
Yes, sir.
So IRMS is basically this much. Let's try to just fit in for a half cycle. Please remember, can you see the period has decreased by half? So if you do from 0 to t by 2 or t by 2 t, is it going to be coming to be same? Will it come same? Whether you integrate it from 0 to t by 2 or t by 2 to t, you are integrating it over a whole complete half cycle, right? Or for this
Yes.
function, complete full cycle, right? Yes or no? So I'll just
Yes.
calculate it. If I want to calculate from 0 to t2 equals to t, I'll just solve it. So I RMS will be equals to under root of 1 by t by 2 minus 0 from 0 to t by 2. Guys, please write with me, na? Please write with me. I square. What was I square? I square was basically I naught square sine square omega t into dt. Yes or no? Yes or no, guys?
Yes. Yes, sir.
So after this, what to do? Will it be equals to? I'll just copy this again. Control C, Control V. Twice of this 2 will come in the numerator. This I naught square is a constant, it will come out. So twice of I naught square divided by t, and then you need to integrate it from 0 to t, and what is remaining inside? Sine square omega t dt. But do you know the direct integration of this thing? If we don't know the direct integration of this thing, we'll use some trigonometric properties. We know this particular thing, that what is the formula for cos 2 theta in terms of sine square? Is it this?
1 minus 2 sine.
Yes or no? Is it 1 minus 2 sine square theta? And can you see from here, 2 sine square theta will be equals to what? 1 minus cos 2 theta, right? So 2 sine square theta will be 1 minus cos 2 theta. So I can write sine square theta is 1 minus cos 2 theta by 2, right? Can I write this? Yes or no? Can I write this?
Yes, sir.
So I'll just write this sine square omega t as twice of I naught square by t was common. I'll from sorry my bad, 0 to t by 2. So 0 to t by 2 sine square omega t. Sine square omega t will become 1 by 2 minus cos 2 omega t by 2. Can I write it like this? Can I write it like this, guys? Enough?
Yes, sir.
Okay. So just name this as equation number 1, and we'll solve the integration part separately. Just for clarity purposes only, na? If you want, I can do it in this only, but let's do it in this only. So IRMS will be equals to under root of twice of I naught square by t integration 0 to t by 2 1 by 2 dt. Yes or no? Hayana minus 0 to t by 2 cos twice of omega t by 2 dt. So basically it becomes like this. When it becomes like this, can you see this half will come out of the integration, guys? थोड़ा सा typical है, I know it's a little bit typical integration, but it is what it is, है ना भाई? So twice of I naught square by t, this will be 1 by 2 out, and when you integrate dt, what will you get? You'll integrate dt, you'll get t, right? And then you'll put the
Yes.
limit t by 2 minus 0. Ayana? Ayana, guys?
Yes, sir.
Yes, sir.
I can still do it like this. T limits from t by 2 to 0 minus this 1 by 2 will come out. Can you see this 1 by 2 will come out? And it will be integration of cos 2 omega t. What is the integration of cos 2 omega t? Sine 12 omega t divided by 2 omega. And the limits will be from 0 to t by 2. Is this clear, guys? Are you writing along with me, everyone?
Yes, sir.
Okay. Can I do this thing? I can just take this 2 common and cancel out with this 2. Is it fine? So IRMS will be equals to, I am taking this I naught square, say I naught also out. I naught. This will be 1 by t left. This will become t by 2 minus 0 will become t by 2 minus sine 2 omega t. Acha, I can take this 1 by 2 omega also out. So 1 by 2 omega, I can write it as 2 pi by t multiplied by sine 2 omega. So sine of 2 into 2 pi by 2 into t by 2 minus sine 0. And one more last. Another. Please write everything very carefully. Na? This derivation is going to be very special because from this I'll generalize something. Na? And you know those general results will be used everywhere. Okay? Okay, guys?
Yes,
Also,
sir.
so now this will become how much? I naught as it is 1 by t into t by 2 minus this will become t upon 4 pi into. Now can you see t and t will get cancelled out, 2 and 2 will get cancelled out. What is sine of 2 pi? Sine of 2 pi is sine 360 degree. What is sine 360 degree? 0. And what is sine 0? 0. So can you see this whole term is what? This whole term has become 0, right? Yes or no? Yes or no?
Yes.
Yes,
So
sir.
always remember, when you do this integration, it will always become 0. Can you see this was a periodic function with period how much? Periodic function with period t by 2, right? Cos 2 omega t was basically a periodic function with period t by 2. And can you see you are integrating it on this full time period only, right? Yes or no? We are integrating it over a full time period. This gives us 0. Always remember, this is a property of integration you will study in grade 12 maths. Whenever you have a periodic function and you integrate that periodic function over a full time period, then always remember the answer is going to become to be 0. So whenever you have cos 2 omega t, seedhe 0. Yeah, because you are integrating from 0 to t by 2, right? Is this clear?
Yes.
Please write down this note as well somewhere. Who has not joined today? I can't see Ishita. I think Ishita is not there. Yes, everyone is there. Ishita is not there. Done.
Yes, sir.
Shall I move down? So can you see the overall thing becomes 0. So always remember that note which I made you write. Whenever you integrate any periodic function, any, not necessarily sine cos, any periodic function over a whole time period, when you are integrating, it will become 0. Okay. So this will come to be, this will be equals to I naught, and only this will remain now, right? Integration of 1 by t into t by 2. T and t will get cancelled out. Can you see over here, I RMS value is basically equal to how much? I RMS is basically I naught divided by root 2. Yes or no? Hi Anna.
Yes, sir.
So this I 1 by root 2 value, can you see 1 by root 2, when you will calculate it mathematically, it will come to be 0.707 times of I naught, which is basically 70.7% of the peak value. So basically, if you want to consider I want the RMS value whenever an AC is represented as a DC. We'll see in questions, don't worry. So whenever an AC current is represented as a DC format, then what we'll do, we'll assume that whatever value is given is basically the RMS value. We'll see in the numericals. Similarly, can I write the same derivation for ERMS as well? Can you see the value of ERMS will be again, what will be the value of ERMS? It will be E naught divided by root 2, or 0.707 times of E naught, or basically 70.7% of E naught, the peak value, please. So this is your RMS value, and this is all about your RMS value and the this thing. Okay. ये बिस्किट जैसा है. Just tell me whenever you're done. Yeah, are you done writing?
Yes, sir.
Any doubt? Non-math students, bio students, any doubt? I know it's a little bit of maths involved, but those were basically derived from the basic properties, right? Everyone, is it clear?
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes, sir.
So एक note लिखें. Whatever instruments which are working on AC, so all the instruments which are working on alternating current, and that includes most of the instrument which you have, right? All of them are calibrated against the RMS value. Please remember, whenever you see this thing, no, जैसे cooker है and fan है, whatever you have instrument, है ना? And when you try to see that instrument, you'd see the power rating, right? Do you remember power rating? Grade chapter 2, current electricity. So power rating, sometimes they mention the current as well. So please remember, if those instruments are calibrated to work against alternating current, so that current value which is given, it's in DC format. It's just written like 2 milliampere or 3 ampere, whatever it is, right? 2 milliampere is, by the way, 2 less, so it will be 2 ampere to, let's say, 5 ampere, whatever it is given. So this value which they mention in the power rating, if that is an AC instrument, please remember that is the value which they mention is basically the RMS value. Okay. So I can write that is they measure. Or just for example, if I have a alternating current galvanometer, AC galvanometer I have. AC galvanometer is basically a galvanometer which is used to measure the AC current, right? So they measure only the RMS values of AC or alternating EMF. These instruments, by the way, please remember these instruments are called as hot wire instruments. नाम है उनका पता नहीं क्यों, I don't know. These AC instruments are basically called as the hot wire instruments. Okay. Suppose example, if I'll give you, if I have a current which is basically equals to 50 times of sine omega t, the first thing you should be able to do this thing. If suppose if you have an AC ammeter, and if you have an AC ammeter, that AC ammeter, what will be the reading in that AC ammeter? The reading will be basically what? I RMS, which is basically what? 50 divided by root 2. Why? Because do you know this is basically the peak value, right? I naught.
Yeah. Yeah.
But this will be basically 50 root 2 amperes. So that AC ammeter will measure only this much. It will not fluctuate. It will not do anything. It will just keep on steady. The needle will be pointed only towards 50 by root 2, whatever it is calculated. When you will calculate, you will get the answer, right? Now suppose what will happen if I connect a DC ammeter across AC source. AC ammeter across AC source. So here in this case, what will be the reading? The reading will be 0. But please remember, we are talking about over a full cycle. Hai na? Over a full cycle, what will happen? Suppose if you have a bi-directional DC ammeter, then that DC ammeter will keep on pointing. It will never point towards one particular value. It will never point. It will just keep on fluctuating in the positive direction, then coming to the mean position, then in the negative direction, coming to the mean position. So over a full cycle, it will point towards the average. Do you remember?
Okay.
So basically, DC ammeter will give you average reading, whereas AC ammeter will give you RMS reading. Did you feel?
Yes, sir. Wait, sir. How do we differentiate between AC ammeter and DC ammeter? What's the difference in them other than the fact that they're AC and
उनका
DC? How do
construction
they?
अलग है.
Okay. Fine.
Both are made of different materials. Both are supposed to work differently. If you are done with this, then we'll start with the numerical part. And today we'll do lots of numericals. And next class we'll do we'll flow the AC current through individual resistor, capacitor, inductor. We'll form the equations. Then we'll connect all of them in series. And then we'll see RL circuit, RLC circuit, RCA circuit. So basically, whatever we discussed till now, we are trying to do just the same everything, but with the help of an AC source, not a DC source. Anyways, question. An alternating current given by I equals to 3 root 2. Namaskar. Sine of 100 pi t plus pi by 4. Now the question is, this is the equation of AC. Give the frequency and RMS value of current. Easy. Is it easy? Just compare this equation with what is the general equation for an alternating current? I equals to I naught sine omega t plus pi. So can you see everything you can compare, and you know how to calculate the RMS current? It is basically the peak value divided by
root 2.
And frequency is basically what? We know omega is equals to 2 pi f. So if you will compare, you'll find omega and automatically you can find the frequency, right?
Yeah.
With the help of these two formulas, you'll be able to get what you want. किचन में शॉर्ट ट्रे जहाँ पे कांच के बर्तन रखते हैं ना, बाउल के अंदर जोंड है, इसके अंदर compare fast. So from comparing, can you see I naught is basically equals to 3 root 2? And from here you can say I naught 3 root 2 divided by root 2, so ye katega and the answer will be 3 amperes. And similarly, omega, can you see omega is how much? 100 pi. So 100 pi is basically equals to 2 pi f. So from here f is equals to 50 hertz. Easy question start, to
Yeah.
begin with. And these type of questions are generally asked in school, direct comparison and then solve. I'll give you next. Voltage of E equals to 60 sine of 314 t. 314 nothing but 100 pi, is applied across a resistor of, सर आपने तो पढ़ाया नहीं, across a resistor connect कर देंगे. So now what will be the reading of current first in an AC ammeter, and the second is in an ordinary. Ordinary is basically DC, right? In a DC ammeter in series with resistor. Both are in series, by the way. Okay, sure हो जाओ. अच्छा, what is the answer for the second part of the question? The second part of the question answer.
Will it be zero?
Will it be zero?
It is zero. So the solution to the second part is basically zero, because all ordinary, DC ammeter will read. DC ammeter reads I average, or will be that too for a full cycle. So we said zero, right? Is it clear? We need to do the first part basically. So can you see the equation which was given to you? E equals to 60 sine of this. So what is E RMS then? Will E RMS be equals to E naught by root 2? Will it be equals to 60 by root 2 volts? Yes or no? Yes or no?
Yeah.
And we know this particular thing, that AC ammeter basically reads the what? AC ammeter reads
IRMS.
IRMS, which will be basically what? E RMS divided by R. For Ohm's law, when you have converted it into DC, you can apply Ohm's law easily.
Yeah.
So 60 by root 2 multiplied by 20. So the final answer will be 3 by root 2. Okay.
Yeah.
By the way, this will be 42.4 volt and this will be 2.21. Next question.
So I had a doubt.
Anji.
What exactly do you mean, like when you say that AC ammeters can only read IRMS? Like, what does that
Because
tell us?
AC ammeter are used to measure the RMS value across a AC circuit. So generally AC ammeter को तो DC में convert करेंगे, मतलब DC में you won't connect, right? What will happen when you will convert AC ammeter to a DC circuit? Will it be giving you any value?
No.
Okay. Or it will give you the value. It will give you the average value. Ask me why. Because in the case of a DC circuit, average value and RMS value are equal.
Yeah.
So it will give you the average value, right?
Mm.
तो वो normally जैसे work करता है वैसे करेगा.
तो इसका मतलब ये नहीं कि हमारे सर्किट में हमें कभी I नॉट देखने को मिलेगा ही नहीं.
Never. You won't be able. You will feel it in normal circuit. मतलब actually there is I naught happening at certain point of time. But when you try to convert that AC to DC, then you will never be able to see that I naught complete. Actually,
Okay.
my I naught is there at one particular or two particular time instants during a whole cycle. I naught is there.
एंड उस सर्किट में अगर हम AC एमीटर कनेक्ट करें तो हमें I नॉट नहीं मिलेगा, हमें
Will
RMS
that
की
AC
वैल्यू
ammeter will measure only the IRMS and it will keep its value at one particular needle only. मतलब it will point only at one particular measurement.
and we don't need to know the reason for
So,
that.
Yes, tell me. हाँ बोलो बोलो.
how should the circuit be if we want to, like, find? We found it here, like ERMS is equal to IRMS is equal to ERMS by R. So, like, how should the circuit be if you have to find, like, E naught or I naught?
Okay. So this is the circuit. This is giving you a value of E is equals to 60 sine omega t. Right? This
Yes,
current,
sir.
whatever current will flow, it will be the instantaneous current, but this AC current will not read this thing. This AC current will not read. The current is going as 60 divided by 20. How much? 3 sine omega t. The current will be flowing like this, but this ammeter will read what? IRMS, which is basically 3 by root 2. So basically, the needle will be just pointing only to one particular thing, only to one particular point, measurement, or one on only. क्या बोलेंगे यार? Only to one particular value, the needle will keep on pointing. The needle will not fluctuate, will not do anything. It will just point to one particular value, which is basically what equal to the RMS value. So basically, by measuring the RMS value from this AC ammeter, you try to find out what is the peak value.
Oh, okay, so the AC ammeter cannot, like, measure I naught. We have to. It can only measure IRMS, and we have to
IRMS,
find
yes.
with that I naught.
हाँ जी.
Okay, sir.
Okay. चलिए next.
So do we have any device which can measure I naught?
No. मेरे ख्याल से नहीं. I don't think so. You can just measure the, suppose if I try to connect the DC ammeter over here, suppose this I have connected a DC ammeter over here, then this DC ammeter will keep on doing what? Something like this. Okay, are you getting my point? The DC ammeter will keep on doing like this. It will keep on going from one side to another side. So basically, whatever value it goes to the peak, that will be I naught. Okay, is this clear?
Yes.
You can measure this I naught like this. If you want to measure I naught, then connect a DC ammeter and let it fluctuate. It will never rest at one particular place. Okay, please remember, DC ammeter will not be able to rest at one particular place. The needle will keep on moving. And please remember, this 50 hertz is not a small frequency. It will not move like a pendulum. Dheere, dheere, dheere. 50 hertz is like basically it's completing 50 oscillation in 1 second, right? So this needle will go like in such a fast manner that you won't be able to see it. Are you getting my point?
Yeah.
The frequency of AC, sinusoidal AC, is 50 hertz roughly अपने घर पे जो आता है, right? If you connect a DC circuit, then will you be able to see the movement of this needle? Itna fast?
No.
You will be just seeing blur images, right? So anyways, now everybody got it. What will happen if I connect AC ammeter and DC ammeter? Shall I give you next?
Yes, sir.
Yes, sir.
The electric mains in a house are marked as 220 volt 50 hertz. Now you need to write down equations for instantaneous voltage. Write down the equation for instantaneous voltage. How will you write it? Acha, by the way, can you see this thing which have, they have given? What is this? Can anyone identify what is this? Is this an AC? We know this particular thing, no? The current in our home is basically what? It's an AC current. Everyone knows this.
Yes.
है ना? But generally, whenever you see a mains, you'll always see this particular thing 440 volts, 220 volts, and they'll mention frequency as well, right? What is this thing mentioned? This thing always, it is equal to basically what? The ERMS. So always remember, this is basically your ERMS, which is basically 220 volt. The frequency is basically 50 hertz. If the frequency is 50 hertz, then I can calculate omega, which is basically 100 pi radian per second. And from this ERMS, I can calculate the value of E2, this thing, E naught. So we know this particular thing, ERMS is basically E naught divided by root 2. So I can say E naught is basically ERMS multiplied by root 2, which is basically 220 root 2. So what will be the equation? It will be equals to 220 root 2 sine of
100 pi t.
T plus pi, let's say.
Plus
Some initial phase difference is there. So that's basically your answer. Clear?
Okay. Yeah.
Next. An electric bulb is designated to operate at 12 volt DC current. है ना? 12 volt in a DC circuit. मतलब when it is connected across a battery, तब उस पे जब 12 volt होगा, then it is able to work that, है ना? Now, if this bulb, the same bulb, is connected to an AC source, and if it gives the same brightness, then question is, what would be the peak value of alternating EMF? Easy है, I'm telling you, easy है. Just go by the definition. अच्छा, give me 2 minutes, I'll be back. Okay. Yes, guys, tell me. What idea did you get from the question? Can you see over here? The
So
question
is
is
the
given.
answer 12 root 2?
Is the answer 12 root 2? Yes, the answer is 12 root 2. See, can you see from here? If the bulbs are giving same brightness in both the cases, that implies what?
I is equal to IRMS.
Exactly. Or you can say the heat produced in both the bulb is same. As brightness is same, that implies the heat produced is same. So in that bulb at 12 volts, the heat is produced to be same. So basically for AC circuit, what will be the ERMS value? 12 volt. If this would be the case, then automatically we can calculate easily. E naught will be equals to ERMS multiplied by root 2, which is basically 12 root 2 volts. Is this clear? Conceptual question? है ना? एक last question more. One more question. No, not last. Still, there are some questions. Good questions are also there. What's the time now? 19:14. We can do all the questions together. So next question. A direct current of 2 ampere and an alternating current of peak value 2 ampere flows through a circuit resistance of 2 ohm and 1 ohm respectively. Respectively मतलब basically क्या? This 2 ampere direct current is flowing through 2 ohm and this AC current is flowing through 1 ohm. Okay, everyone, question clear hai? Now the question is, find the ratio of heat produced in the two resistors in same time interval. In the same time interval, what is the ratio of heat produced in both the cases? Always remember, if you are not clear about the question, always try to draw the diagram. है ना? This is a 2 ohm resistor, and through this 2 ohm resistor, what current we are flowing? We are flowing a current of 2 ampere, right? DC circuit. And through the 1 ohm resistor, we are flowing a current whose peak value is how much? 2 sine omega t. We are flowing a current like this. Can you see the peak value? Peak value is given. Yes or no? Is this the question given to you? And they are asking what is the heat produced in the same time interval, right? Yes or no? So here the heat produced will be equals to what? I square into R into, let's say, the time interval is T. So I square will be 2 square into resistance is 2 into time is also 2. This is your H1. And for this, what will you do? You will convert it to a DC circuit. This AC circuit will get converted to a DC circuit with current how much? Will the current I not flow through this circuit? If I am converting AC to DC, so will a current of I not flow through this 1 ohm?
No.
Then what will the current flow?
IRMS.
Very good. So IRMS current will flow through this 1 ohm. And what will happen now? The heat produced in this circuit will be equals to what? IRMS. So if I naught is 2 ampere, what is IRMS?
Root 2.
I naught by root 2. So 2 divided by root 2 ka whole square into R into. So can you see H1 is basically 8 times of T and H2 is basically 2T. So if I calculate H1 to H2, it will be 80 by 20, which is T city kadega. It's a 4 answer. Numerical type, numerical based questions. Okay. Is this clear, guys? Everyone understood what exactly are we doing? Shall I give you some more?
Yes, sir.
Now suppose in a circuit, in an AC circuit, the net current through this particular thing, the net current flowing through the circuit is given by I is equals to I1 sine omega t plus I2 cos omega t. इसका मतलब क्या है सर? There are two sources connected in the circuit and both are producing current, the AC current, and one is producing this and another one is producing this. So by superposition I have written this equation. Okay, so now the question is, find the RMS value of this. How will you find the RMS value? Everyone knows the formula how to find out the RMS value, right? This will be a homework question, by the way. Everyone knows how to find out the RMS value. Under root of T2 minus T1 from T1 to T2. Where to where? People? Where to where? I dt, right? So first approach is basically this. You can directly just put the value of this I over here and you'll get the answer, right? I'll leave the integration to you people. The second approach I am more interested. I is equals to I1 sine omega t plus I2 cos omega t. Now, can I write omega t as theta?
Yes, sir.
Or in spite of not doing that, can I write I1 as some I naught cos theta and I2 as I naught sin theta? Sir, why are we doing this trigonometric, special type of trigonometric substitution we are doing? Why do we need to do this thing? You'll just, see the reason why exactly am I doing this. So if I put this I1 as I naught cos theta and I2 as I naught sin theta. So can you see over here, I becomes equals to I naught cos theta sin omega t plus this becomes I naught sin theta cos omega t. Does it become like this? Can I take I naught common?
Yes, sir.
If I can take I naught as common, then can you see cos A sin B sin A cos B? Is it something?
Sin A plus B.
Yeah.
This will become how much? Can I write this thing as sine of omega t plus theta, sine of A plus B? So can you see, this is again a general equation of current, right?
Yeah.
So I can convert this form to this form by using this special type of substitution. Okay, this is a problem specific substitution only. It's not a concept,
Fine.
it's not anything, it's a problem specific. मतलब कभी भी ऐसा दे, you can do it like this. And now from here, what was this I naught? I naught was basically the peak value of this resultant current, and theta is basically the initial phase of this resultant current. So can you see over here, I can solve what is I1 and I2. I1 and I2 were given in the question. So from equation 1 and 2, from 1 and 2, can I write I naught is equals to, or basically I can square it and add it. So I naught square cos square theta, I naught square sin square theta, cos square theta plus sin square theta will become 1, right? So I naught square will be equals to I1 square plus I2 square, and I can find out I naught is basically under root of I1 square plus I2 square. Can I write it like this? Well, what was I naught? I naught was basically the peak value. So what will be the RMS value of this current? RMS value will be what? What will be the RMS value?
Root 2.
है ना? This I naught, oh sorry, my bad, I naught divided by 2. So what will be my final answer? For the resultant current, the final answer will be under root of I1 square plus I2 square divided by 2. And that's my answer. Is this clear?
So the first approach is complex, yeah, or
It
to be
is,
following?
no, it will be like 3 different integrations you need to do. You'll, whenever, oh sorry, my bad. So when you will square it, will it become I1 square sine square omega t? This will become I2 square cos square omega t plus twice of I1 I2 sine omega t cos omega t. So you will multiply that 2 into the sine omega t cos omega t, it will become sine 2 omega t, right? And then
Yes, sir.
integrate across 0 to t. So you will get your answer, final answer. Okay. Is this clear, guys?
Sir, is there any reason behind why we took I1 as I0?
Nah, मैंने क्या बोला?
Done.
It is basically a problem specific substitution. In maths, you will find these type of problems where it is in the form of a sine theta plus b cos theta. So you generally do what? You put a as r sine phi. No, sorry, a as r cos phi. Why a as r cos phi? Because can you see this cos phi and sine theta and cos phi can get multiplied and become what? Sine theta cos phi. And you'll write b as r sine phi. So it will become just the way it was. These type of substitution I already used in grade 11 when we were doing vectors, right? So anyways, this is problem specific substitution. So if this problem comes, then remember this substitution like that.
Okay, sir.
Chalo. Next question. Do you remember the decay of current in an LR circuit? The decay of current in an LR circuit, I'll write the formula as well, is given by I is equals to I naught into e to the power minus t by tau. Where what was tau? Tau was equals to R by L, right?
Yes, sir.
R by L था कि L by R था?
So R by L.
R by L पक्का ना?
So I'll check.
Check please, फटाफट go check. Even I'll check. Then I check. LC oscillation.
So tau is equals to L by R.
L by R, no? So we know this particular thing. Tau is basically equals to L by R, right? But keep it in terms of tau only. I want the answer in terms of tau. So although the answer will not have tau, okay? where tau is basically what? L by R, and this is basically the time constant, right? So now the question is, find the RMS value of this guy. Of this current for the period of t equals to 0 to t equals to tau. Assume what is the current initial current is how much? I naught, right? I naught is basically the initial current. Do you remember this? So this question is nothing but you need to apply integration formula. You need to do again the same. IRMS is basically equals to. Can you see this is not alternating? This is not an alternating current. I am just asking you to find out the random value of this random current. So basically you need to just perform this integration and that will be your answer. So I'm leaving this as a homework for you people. The answer to this will be equals to I naught by root 2 into under root of 1 minus 1 upon square. Okay. This will be the answer for your IRMS.
So in this question, do we just substitute for I
Exactly.
and then find it?
Integrate then.
Okay, sir.
Okay. So the next question. In a wire or in an AC circuit, a a DC and an AC. Okay, I can write the value of that DC and AC. A DC current I1 and an AC I2, which is equals to I2 naught sine omega t is superposed. Whenever anything goes superposition, the net current is basically the sum. Right? So find the RMS value of the resultant current. I'll teach you one approach, in this particular thing. Sometimes, you don't need to calculate the direct, the whole thing, right? So first of all, what is the net current through the circuit? The net current through the circuit will be basically the superposition of I1 and I2. So I can write it as, this is by principle of superposition. We'll discuss it later on, what is principle of superposition. And those people who already know what is principle of superposition, as we discussed in grade 11th, also in grade 12th as well, the vector sum of all the forces, right? So you basically add it vectorically. If there is current is a scalar, then you'll add scalar, no problem. So this will be I1 plus I2 naught sine omega t. Will this be the net current through the circuit? Will this be the total current in the wire? Yes or no, guys? Yes or no? And I want to find out what is the mean value of this thing only. So can I write this particular thing IRMS? How much? IRMS is basically under root of I square average. Yes or no? याद है आपको? So let's calculate I square average. And in spite of doing that, I'll do this thing. See. So it will be equals to I1 plus I2 naught sine omega t whole square. So I can write it as I1 square plus I2 naught square sine square omega t plus twice of I1 into I2 naught sine omega t. Can I write it like this? Guys, can I write the I square directly like this? Yes or no?
Yes, sir.
So can you
Yes,
see
sir.
that this function contains of three different functions? So if I want to find out what is the average value, you can use this concept later on and you can thank me later. You don't need to perform the whole integration. Can you see this is a time independent function? So no dependence on time. So even if you integrate on time, will it make a difference to this?
No.
So what is the average value of I1 square over a whole time period? Will it be equals to I1 square only? Yes or no? Plus. Now tell me, I2 naught square. Can you see this function also be integrated once? Anna? Or in spite of doing this, you can just remember this thing, I2 naught square. You can write as it is. And the average value of sine square of theta. The average value of sine square theta is basically 1 by 2. Okay? You can write
Yeah.
the reason as well. Average value of any function sine square theta is basically 1 by 2 over a complete time period. Okay, over a complete cycle. Similarly, what is the integration of sine omega t? We know this thing is the integration of sine omega t over a full cycle is basically what? The integration of sine omega t over a full cycle is basically twice of I1 into I2 naught, and you will write this as, why did you write it as 0? This is basically the average value of sine theta over a full cycle. We already did these type of both the derivations we did, right? Over a full cycle sine theta is 0 and over this thing sine square theta 1 by 2. Sir, how did you get 1 by 2? Can you see over here? When I integrated RMS current, do you remember when I did integrate this thing, what was the final answer which I got? Only this term was left, right? And can you see over here that too t and t got cancelled out, right? So what was the final thing which I got? 1 by 2, right? So always remember this, with the help of that only we are directly writing this. Okay. So what is the final current? What is the average value of current? Can you see without doing integration, I try to find out what is the average value of I square, and this will be equals to I square and this will be equals to I2 naught square divided by, and this will be 0. So that is basically your I square average. Now what is the IRMS? Is under root of I square average, which is basically under root of I1 square plus I2 naught square divided, and that's your answer. So you can use this approach as well.
Okay, sir.
But please remember, this result which you know is only for sine theta, sine square theta, cos square theta. Also, है ना? Please remember this thing. Cos square का भी average value will be 1 by 2 only, and cos omega t over a full cycle will again become 0. Is this clear, guys?
Yes, sir.
So that's it for effective current, RMS current, average current. We discussed lots of problems. I think problems are pretty much clear. Some concepts we learned new, some direct results we tried to acquire. So in the next class I'll start connecting alternating current source between various elements. Like first I'll connect it across resistor, then inductor, then capacitor, then I'll take a combination, series combination specifically, because in JE syllabus only series combination is there, and in advanced syllabus you have parallel combination as well. So I'll just tell you how to deal with parallel combination. I'll not exactly do the whole thing, or we can do them later on when you will be doing the revision and when you will be selected for advanced. So we'll do only the advanced portion. Okay. So is this clear, guys? Any doubt?
Yeah.
Doubt है?
नहीं.
अच्छा, चलो ठीक है. Okay. We'll see you again. Bye bye. Take care.
Thank you, sir.
Okay.
Thank you, sir.
Thank you, sir.